Hi everyone, today we'll be learning about the page replacement algorithm which is under operating system, OS operating system. This is B.Voc class, and then we are going to learn about page replacement algorithm. Before going into the algorithm part, we have to know what is page. In a computer, there is a memory, what is so called hard disk or secondary memory. This is secondary memory. This is the hard disk and secondary memory, and then there is main memory, which is also called, which we generally known as RAM, the RAM. This is the RAM. Suppose in the hard disk there is a file, there is an application, there is a process. Let's say this is the process P. To execute this file, this process has to be swapped into the main memory so that it will be executed from the main memory. We cannot execute the process from the secondary memory directly, so we need this process to be in the main memory. This secondary memory is like maybe 1 TB for example, and then main memory is very small, like 2 GB, 4 GB or 8 GB, whatever. If we can see the size, main memory is very small compared to the secondary memory. It's secondary memory, so it can happen that this one process is larger than this whole main memory. So let's write like this is the process. This is a process, and we have to fit into the main memory. Since the process, a process alone is larger than the main memory, we cannot put the whole process in the main memory alone. So in this case, the concept of virtual memory is coming, and then virtual memory is just some part of the secondary memory. Since that is not our topic, we won't go through that. Instead of putting the whole process in the main memory, we can divide the process into equal segments called pages. This is called a page. This is called page. And page number 0, 1, 2, 3, 4, 5. Let's say, for example, page. Suppose this is 1 MB. This page is 1 MB. Everything will be 1 MB. 1, 1, 1, 1, 1. This page is of equal size. Instead of putting the whole process in the main memory, maybe we can put this process 3 in the main memory at first. This is in most of the case, the process can be divided into many parts, and one process or two processes at a time will be loaded into the main memory. The main memory is also divided into equal segments called frames. So suppose page number 3 is loaded into the main memory 3. Suppose page number 3 is loaded into the main memory, and in the next request, page number 2 is loaded into the main memory again. So for 2 to be loaded in the main memory, since there is no 2, there will be page fault. There will be page fault here, and 2 will be there. And in the next request, suppose 3 needs to be loaded into the main memory. If 3 goes here, since there is 3 already here, there will be no page fault. So that is the case for page fault and page. To keep track of which page is in the main memory, there is a page table. this is a page table. These are the frames, and then this is the valid or invalid. So we can see here 3 and 2 are already in the main memory, so they are valid. Okay, for another case, let's say page 4 needs to be loaded into the main memory. This is page number 4 is going to the main memory. Since there is no 4 in the main memory, it is invalid. So when we put 4 into the main memory, there will be a page fault again, 4. And then when we put 4 will become valid. That is how the page table is filled. Whenever we put a page from the main memory, and there is no page in that memory, that is called page fault. Now let's for putting these things together, suppose there is only 3 frames allotted for this process. Suppose there is only 3 frames allotted for this process, and then these frames are already filled by 3, 2, and 4. Suppose one is requested by the main memory. Then for this one to fit into the main memory, one has to be swapped out. One has to be replaced, which any one of these frames has to be replaced by this one. So we have to replace any one of these. Let's say we replace 4, 1, like this. For this replacement, there are different page replacement algorithm. This is the page replacement. The first page replacement algorithm, first in, first out. First in, first out. Suppose there is a reference string 1, 3, 2, 1, 4, 1, 2, 5, 2, 3. Then reference string. This reference string is, each of this is the page number. We know that the page, this is a process, this is page 0, 1, 2, 3, 4. This 3 is this page. These are the frames. Frames means in the main memory, the segments are called frames. We assume that it is assumed that at first the frames are empty. So when page number 3 is requested, it will be located in any of the frames. Let's say F1, 3. Since there was nothing here, and 3 is loaded into frames 1, there is a page fault. And then 1. Frame 1 is still filled with page 3. 1. Since there is nothing here, it is a page fault. Then again, no, 4, let's say 3, 1, and since there is still empty space, 4. Now there is 2 here, there is no 2 in the frames, so we have to replace one of these 3 frames, one of these 3 pages from these frames. So which one are we going to replace? That is decided by the first in first out algorithm. See, 3 is the first page to come in, right? So 1 is here, 1 comes here, 4 comes here, 4 comes here, so 3 is the first one to come in, so we have to replace 3. So 2, since we are replacing, there is a page fault, 2, 1, 4. And then next comes 1. 1 is already in the frames, so it is a hit. HIT, hit, just in case. So there will be no change. 2, 1, 4. And then next comes 4. 4 is already there in the main memory in the F3 frame number 3. So 2, 1, 4, no change. This is also a hit. And then 1 comes again. Hit again. 2, 1, 4. 2 again. Now 5 comes. There is no 5 in the frames, so we have to replace one of these 3 pages. For that, first in first out algorithm, we will be using it again. 2 comes here, 2 comes here, 1 here, 4 here. So 1 is the first one to come in, so we have to replace 1. This is a hit. This is a page fault. 2, next comes 2. 2 is already there, so no need to change. So this is a hit. This is how the frames are filled when there is demand paging. So number of page fault. Number of page fault is equal to 1, 2, 3, 4, 5. And then there is a term called hit ratio. There is a term called hit ratio. Hit ratio means number of hit 1, 2, 3, 4, 5. Number of hit by total number of the reference string. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is the hit ratio. This is the first in first out algorithm for page replacement algorithm. Next algorithm for page replacement algorithm is least recently used. We are going to use the same reference string. Least recently used means which page has not been used for the longest. We can say it like that also. First of all, 3, nothing, page fault. 1, page fault. 4, and then 3, 1, 4, still page fault. True. Now, least recently used. We have to change one of these pages, one of these frames by true. Now we have least recently used algorithm. Least recently used algorithm. In least recently used algorithm, from the current position, we look towards the left. We look these frames. Which frames has come farthest to the left of current position? 4 here, 1 here, 3 here. 3 is the farthest, so we have to change 3. 2, 1, 4. This is a page fault. One is here. Next is 1. 1 is in the frames, so it is a hit. 4 is also here, so it is a hit again. 1 again. Well, I hit 2, 1, 4. Both are hit. 5 comes. Now 5 comes. We have to replace one of these pages, and we have to replace one of this page with 5. So which one are we going to replace? Least recently used. We have to look this number, and from this current position we have to look to the left, which is the farthest. 4 is here, 1 is here, 2 is here. So 4 is the farthest from current position, so we have to change 4. This is a page fault. This is true. True is already here. It is a hit. So number of page fault: 1, 2, 3, 4, 5. 5 again. Hit ratio is same for this case, 5 by 10. So this is the least recently used. Let's explain it once again. Suppose there is, we have to change from 3, 1, 4. From the current position, we look towards the left, and from the page which are already in the frames, we have to choose which one is farthest from the current position to the left. 3, 1, and 4. 3 is the farthest, so we have to change 3 with true. That is least recently used. Next is optimum page replacement algorithm. With the same reference string, we are going to do the optimum page replacement algorithm. So the first for 3 frames, in many cases, this is just an example for 3 frames. There can be 4 frames, 5 frames, or many frames. This is just an example of 3 frames. So first 3. Since it was empty, page fault. 1, page fault. Then 4, still empty. Frame 3 is still empty, so it is a page fault. True. optimum page replacement. True. For optimum place replacement, from the current position, for changing this page, we have to look toward the future, which is not possible in real life. For 314, we have to choose which one is farthest to the future. So 1 is here, 4 is here, 3 is not there anymore. 3 is not there in the near future or in the future. So we have to change 3. 2, 1, 4. This is a page fault. And then next is 1. It is a hit. 4 is already there. It is a hit. 1 comes again. It's already here, so it is a hit. 2, it is a hit again. Now 5 comes again. From the current position, we look towards to the right, checking what is there in the frames 2, 1, and 4. So we have 2 is already here, 2 is already here, 1 and 4 is not there in the future. So we can replace any one of these 4, 1 and 4. Best thing to do is to use first in first out for this case, since there is no 1 or 4 in the future. So the first one to come in is 4. So 1. So we have to replace 1. 2, 5, and 4. It is a page fault. Then 2 comes again. 2, 5, 4. It is a hit. Five again. This is optimum page replacement algorithm. This algorithm is not practical in real life because we have to know what will come next, which is not possible. So this page replacement algorithm is just for a benchmark, or like it is not practical. But in this example, V4 is having hit ratio of 5/10. LRU, least recently used, is having hit ratio of 5/10, and this hit ratio of 5/10. This optimum page replacement algorithm will always give the best hit ratio. In this case, it is same, because the example is not a very good example, but just to know how the algorithm works, it is enough. So these are the 3 page replacement algorithm.